The next part of chapter 6, weathering, mass wasting and erosion, we are going to go directly to a second type of this, which is the mass wasting. As I said before, mass wasting means that it's not weathering. Weathering means that there is some kind of disintegration in place. Mass wasting means that part or blocks of this material or of this rock are leaving the origin, the mother rock, and falling down, going away, anything that would take pieces of this rock away. So mass wasting is the transfer of rock and soil downslope under the influence of gravity. So mass wasting is always affected by gravity. Material on top, parts of it, imagine that you have a mountain, and this mountain, part of the rock falls down. This is mass wasting. The mountain lost this part because this part left it and toppled away. So if you go, by the way, to do this, I exerted a lot of effort. Why? Because mass wasting is subdivided into many types. If you go to one book, you will find that you have something called rock slide, mud flow, landslide, creep, lots of items. You will find yourself confused. All of them are called mass wasting. Either you take all of them and put them under one title, which is mass wasting. So all of these types are called mass wasting. But if you want to subdivide these types, you will find lots of confusion between many textbooks. So what I did is that I gathered from all what I have read, divided mass wasting into 5 types. These 5 types are called, the first type is called dots. Dots means there is something that we are going to add here, then called falls. So from the name, it is something falling. Then I have something called dots, then slide. So it is something sliding. So it is falling, sliding, but also something topples or slump. So it's toppling, it's going down a very high place or a high place. Then something flow or creep. Then something spread. These are the 5 types. What can we put here? We can put here anything from here. It may be land, it may be rock, it may be mud, it may be slope, it may be anything added here. So you may have land slide. So it depends, it goes to number 2. I may have rock slide, I may have rock falls, I may have rock topple. All of these, so it is not important what is the material that is being affected. Here, mass wasting depends on the shape of the wasting, not the material itself. Falls, I may have rock falls. Any pieces of rock falling. A slide, as I said, rock slide, it's okay. Landslide, it is okay. This is different terminology. As I told you before, the problem with geology is the lots of terminology. If we can group these terminologies into groups, it will be easier for us to understand what they say, because as I told you, if you open any reference, you will find lots of combination. But this will gather all the combination into just 5 fixed groups. Let's study each one alone. The first thing is called falls. Something falls. Example, rock falls. What is falls? If I have this high level of rock and this is the low level, pieces from the top will fall down. So it is rock falls. This is an example of rock fall. You see that it is important because it destroyed a house. So it is important that you know what is rockfall, so that you would either design your building away from the rockfall or prevent rock from falling. Both are possible in geotechnical engineering. The second is slide. What is rock slide or landslide or anything slide? It means that instead of falling as debris and pieces, it's just sliding down, as if you are sliding in when you are small, going to the park. So sliding is just this amount of soil was on top, then it slided down, covering a highway. A very big problem, and maybe casualties or lives spared away. Toppling and slumping. What is toppling? Instead of pieces falling, no. As if you have a cake and you are dividing your cake into pieces, and these pieces start to topple, to fall. So this is the rock. Due to cracks or cracking that would happen due to many reasons. These cracks, once it happens, big chunks of rock falls down, so it topples and slumps. Flow and creep. Of course, from the name flow and creep, it means that this material is not solid. It is a little bit soft. For something to flow or to creep, it needs to be a little bit soft. So if I have a slope, and this slope is made of a soft material, so this soft material will not topple, it will flow. Just this flow may be very weak, or very slow, and it may be quick. By the way, there is a very famous video for they call it a mountain moving. Mountain with trees, and you see it in this video as if it is sliding down or moving down down a slope. So this, by the way, would be the same. If I have trees here and I'm taking a video from this location, I will find these trees as if they are going down the hill. So this is flow. The last thing is called spreads. What is spread? I may have something called rock spread. What is spread? Spread is pieces of rock. Due to the effect, you remember that we said that in the tectonics, plate tectonics, we said that we may have something called the seafloor theory. I will just show you, yes, this shape. You remember that we said that these layers may be splitted and move away from each other. Once they move away from each other, there is a gap here that will be formed. So this is exactly what we are saying, rock spread. If I have this piece of rock and this piece of rock were once one piece, but what happened? They separated, or they were separated. So when they were separated, water came inside to fill the gap in between. Sometimes it's not water, sometimes it is magma from below coming on top and filling the gap. Now we go to how to prevent mass wasting. Before that we said how to prevent weathering, and we said that we don't need to prevent weathering. But do we need to prevent mass wasting? Of course. You've just seen few photos of mass wasting that is covering buildings, covering houses, covering roads. So I have to prevent mass wasting. Again, geology defined a problem. Geotechnical engineering can provide solution for this problem. Solution may include reshaping of the slope. If I have a steep slope, just reshape it to be milder so that nothing would fall. Using retaining walls, put a retaining wall at the end of the slope so that anything that would fall would be catched or would be prevented by this retaining wall from going to the structures below. Using wire mesh, shotcrete and rock bolts. Try to fix big pieces of rock to prevent them from falling down. Using cultivated slope. Sometimes when this slope is not rock, it is made of something like this one that we have just seen. If I manage to put roots of material very deep below, they will penetrate the layer that is about to move and fix it to the layers that are below. So if I manage to add plants and trees and any type of cultivation, I am helping this slope to be stable. Let's study each one alone. How to prevent my mass wasting by reshaping. This is the original slope, and I found that this slope is about to fall. If I myself take this and remove it away, so in future it will not fall, and the slope will be better. Maybe not just take a piece of this, or maybe take a milder slope. It starts from here, ends here. It will help to make the slope safer. Use retaining walls. Here is a retaining wall, here is a slope. Anything that falls from here, it will not reach this location. Why? Because there is a retaining wall that prevents the slope, anything falling to reach below. Use wire mesh and shotcrete and rock bolts. These are rocks, and I'm afraid that this rock would fall down. I will use this type of rock bolts or anchors just to, as if I am fixing the rock in place. Sometimes I use something called wire mesh. Wire mesh is wires, it's a mesh of wire, and I fix it so that anything that would fall inside, it would not go outside and fall on people below. This is what I said about using cultivated slopes. If I have a slope like this, if I put trees here or any type of cultivation, the roots will help in fixing this slope. The third type to study in this lecture is erosion. At the beginning we said what is the difference between weathering and erosion. Weathering was in place, but what about erosion? Erosion is the physical removal and or transportation of material or weathered rocks by mobile agents such as water, wind, ice. So erosion is the thing that comes after weathering. I have weathering, so I have weathered rock. Pieces of weathered rock will be transported from one place to the other using erosion. I have three types of erosion. Wind erosion, I added here abrasion because both are similar in something and different in another thing. This is what we are going to see. So I have to differentiate between erosion and abrasion. Then I have glacial erosion due to effect of ice. The thawing of ice, melting of ice, when this glacial move, it makes some kind of erosion. Then I have water erosion. This erosion, by the way, this photo is probably in Egypt in the white desert. This was once rock till this level, but what happened? Erosion happens. It happens due to wind erosion. Wind coming and taking the debris of this weathered material. So this material weathers and then wind takes it away. So why this remains? Because this was more stable than the other. So it is still in place. But other rock has already gone. Just to differentiate between wind erosion and wind abrasion. In geotechnical engineering, we have something called sand blasting, if you have heard about before. Sand blasting, I use a pump, as if we call it a gun, and we put sand in this pump, so it pumps air, including this sand. So what happens? It abrades anything in place. You remember, you both may know what do I mean. Sometimes in cars, when cars are going in the desert, you find that some people cover the face of the car with wax. Or if they don't have wax, they use any kind of soap. Yes, any viscous material, they cover the front of the car. Why? Because when they go in the desert, your lamp bulbs will be eroded. The sand will erode everything. So you are going in the desert. The sand, the wind is not coming alone. It is coming full of sand particles. These sand particles takes anything outside. So you put this viscous material, so it catches this sand, and once you arrive to your destination, just put some water, it will take everything away, and your car will be as it is. So this is similar to what we do when I have rusting in steel. I bring something called sand blasting. I do this intentionally. I take a pump, I pump air full of sand, so it erodes anything on top of this steel. I remove the rusts. So wind abrasion means the effect of wind carrying abrasive material like sand. So the effect of wind including sand is abrasion. The effect of wind alone is wind erosion. So wind erosion is wind alone. Wind abrasion is the effect of wind carrying sand with it. The second type of erosion is called glacial erosion. You have seen this photo before. We used this photo when we were speaking about Wagner, how he proved that in this place was in a very cold area before, and it was found in a very hot area. So he proved using this photo or similar photo that the continents are moving. So actually, what are these? This is ice. This is glacier. It is moving. Why it is moving? Because the temperature are not fixed. It a little bit increases. Once it increases, this glacial start to move. When it moves, it leaves these traces. It means that it is eroding the rock. Leaving a trace means that it is taking part of the rock with it while going. So this is called glacial erosion. The third type is called water erosion. Water erosion is erosion due to the effect of water. It is either sea erosion or river erosion. This is a river, and this is after the flood. The flood comes, it takes the shore with it, and all of these areas were eroded by the river. Here, this building was just watching on the shore of the sea or of the ocean. But because of the effect of the sea erosion or the ocean erosion, this building is now in the sea. Third thing is how to prevent erosion. So we said that we don't need to prevent weathering, but we need to prevent mass wasting. Then the third type, it's erosion. Do we need to prevent erosion? Probably yes. Probably yes. Why? I will just say now. Usually, erosion also takes millions of years. But sometimes, due to my geotechnical construction, I need to protect my geotechnical construction. Usually, if I leave the sea as it is, it has been like this millions of years. So, if the sea is eroding an area, it will still erode this area. If it is not eroding, it will not do anything to it. So, if it is eroding the area, I will just move away out of this. You remember, I don't know if you remember or not, but there is a place in Egypt called Baltim. Baltim is known for just build few buildings. Each year the sea takes the first row from this building. I've been there a very long time ago, and I've seen this. Buildings are eroded by the sea. Every year the sea takes, of course they are not buildings, just, they know that it will be eroded, so they just build small buildings so that once it is taken away, they just build others behind it. But sometimes I need something like Burj Khalifa Bridge. It is built inside the Gulf. This is a new construction. If I leave it like this, the sea will erode it. So I have to protect it. There are many, especially in Dubai, many new constructions inside the Gulf. And in many places you find new construction, or maybe something like this. You know what is a levee? In Arabic it's called lisan. If I want to construct in many places, when you are you have a touristic village on the sea, and you want to let people move on a levee to go inside the sea and come back again. So I need to construct something inside the sea. If I put it next year, the sea will take it away. So I have to protect it from being taken away. So what I would do, I will add something. In case of sea erosion, it means that I have waves. So if I manage to put something to break these waves, so the force of the wave will not reach my new construction. So this is what they have, what they do. They put these big pieces of rock. These big pieces of rock, when I put them in front of my construction, once the sea start the waves will come, and instead of having big force, it will be broken down into smaller forces on these rocks, and rocks will not be affected. So this is what we do. Here it's said that only water erosion is fast and may affect our structures. And I add here that it is, yes, it is water erosion, but in some cases I don't need, but I especially need to protect my buildings from water erosion if I'm having new constructions next to the shore or inside the sea itself. This is the levee I was speaking about. Of course, this was not there millions of years ago. It was recently constructed. If I leave it like this alone, what will happen? The sea will erode everything and it will be sea once again. To keep it in place, they put these. You have seen this maybe in Alexandria, next to the Corniche, next to the shore of the sea. In some places they find that the waves are strong at this area and it may affect the shore, so they put these blocks They put blocks, and in some places they put this shape. But blocks, of course, it is easier. Just big blocks, and they put it next to each other. So seashore and levee protection are needed for some places similar to what you see here. This ends up our lecture for today. Our lecture was weathering, mass wasting, and erosion. We studied the three types and different subcases of them. We said that we don't need to protect ourselves from weathering, but we need to protect ourselves from mass wasting, and in some cases of erosion, we need to protect ourselves. This is the link between geology and geotechnical engineering. To protect ourselves, we have to define when we need to protect ourselves, and then it will be our next years to study how to protect ourselves from this type of weathering, mass wasting, or erosion. Thank you, and see you next lecture.